Hello and welcome back to Happy Houdini Sundays, where I show you what I've learned this week. Okay, for these situations, I always recommend you to take some reference. You always need the reference for everything. And if we study a little bit the effect, the technique, we see that are like streams of energy that are flowing around a sphere, but always targeting the center of this sphere. So we can say that for our particle simulation, we need two type of movements. One that makes our particles move in this direction around the sphere, and another one to pull them toward the center of the sphere. So as you can imagine, these arrows are representing the vectors that we need to implement into our particles. So first of all, we don't need this geometry, we need the points. I will take a scatter node, don't relax iterations. So now that we have our particles, we can start with our popnet. And you can make everything with the pop nodes, but I'm gonna work with geometry pop because it's the easiest way for me. Okay, so for make them pull to the center, we can just take the position of our points and subtract to a 3 float constant, and this inputs into the velocity. Now our spheres are pushing out of the sphere, but because of the subtract is we have to invert it. So now the particles are pulling in, and we can normalize this velocity. Okay, for the second vector, where we want to make the particles flow around our sphere, we also have to take the center of our sphere and subtract the position of our points, but we want to use cross product. And now our particles are flowing around the sphere, but as you can see, they are taken out of the sphere completely. Okay, to solve this, we simply have to change the life expectancy and life variance of our particles, and we can say, I don't know, like a quarter of second and half a second. So now we have this, and now we can add the two vectors. I plug this in and wait, this one there, and now we can have what we want. So this looks very static, to be honest. And the solution for this, I applied a transform here that adds a little bit of rotation with the frame. You can also add this script to any other axis. Now that we have our main movement prepared, it's time to build the effect. And for this, I'm going to go back to the reference to show you that we have two different layers. In one hand, we have the lines or the streams, and on the other hand, we have this kind of energy field that we will make it with a smoke simulation. Okay, first of all, what we need now is to convert these particles into lines. Okay, so for this, in the popnet, we have to deactivate in the attributes tab on the pop source. We have to uncheck this, the add ID attribute. Before the popnet, we can add an attribute wrangle and tell him to create an attribute ID. So I changed the layout to see my geometry spreadsheet, and now you can see our ID attribute. After the popnet, we take an add node, and we're gonna make the same as the lightning tutorial and connect the particles by the ID attribute. Now we don't have anything in the viewport because there are only we are in the frame one and we don't have any particles. But if I move in timeline, so they start to appear. So the lines are a little bit tricky and there are a lot, to be honest. This will change in a moment. But first of all, we need to turn up the resolution of these lines. So we need a resample node. I'll tell him to make 0.01. And in the treat polygon as, we select subdivision curves to smooth the curves. Okay, because there are a lot of streams right now, we can lower the first total count of the scatter node. I think I'm gonna make like 500, maybe. Maybe we can make 250. Yeah, it's just to visualize it better. Now in the resample node, we can check the curve num and curve view attribute. But first, I'm going to delete some attributes that we don't need. And I think we only need the ID to build the effect. Okay, so after the resample node, we can add an attribute bob, add some color to our streams, bind import. We take the curve view attribute that we created and a run parameter. Okay, for the color, I want the center um, to be white. Uh, the other extreme, I want a bluish color, and I want something in the middle that makes turquoise. Yeah, I think this works to me. So when the effect starts, it's really fast. I don't like it. I want to use some backs to run out a little bit of animation in this. So I just created this piece of code. This attribute wrangle says where the animation will start and the duration of it. And this one will make the animation based on the set moment. So as you can see, starts a little bit after. Maybe we can put the color after this code, and now we have our animation. Okay guys, so after several tests, I've come to the conclusion that we can stack several layers of the one we've built. And by combining them, we get a result that is more accurate to the reference. So, as we mentioned earlier, we take our sphere and scatter some points into that. Take the ID attribute. This is where it changes everything. The three streams have the same structure. The only things that change are the transform node. This one is rotating into the y-axis, and this one is rotating in the x-axis. But you can play with the velocities and everything. And into the popnet, inside our geometry bob, we can play also with our cross product. In this case, this sphere rotates in the y-axis, but the cross product is in the x-axis. This gives us this result. The cross product is making the rotation in this axis. You can change this. It's really funny to play with this. You can also add here one. What I add is a vector to vector 4 because I added two curl noise just to make some sort of little bit of variance in the movement. And the cross product and the other vector, I added a multiply with a constant to control the influence of every vector, this one and this one. And I also multiplied the cross product by a ramp based on the age to make the particles go faster as they get older. So that's it, the pop simulation. And this is how the three simulations looks like. Now it looks like a total mess. Every simulation has 500 streams because of the scatter node. But now, after merging this and deleting everything I don't need, I delete the streams I don't want based on a percentage. And now the effect looks like this. I think it's much cleaner. Well, so from here I took the lines, and for the smoke I take a pop net, and I show you what I did. I just want to keep the sphere shape for our smoke and keep the streams. And I did this with pop attract based on points, and the force are these ones, and the maximum distance. I want some particles to be a little bit free to make them go outside of the sphere, and a pop drag to make them slower, take a little bit of variance. Speaking of variance, in life expectancy I have parameters. Okay, the source is on the points. I add them some color based on the distance from the center. I delete the ones that are on the center on the simulation. And after this I deleted the attributes I don't want to, except of the velocity, but I think I didn't use it at all. So I add a pyro source to create a smoke source that gives me density and temperature. After this, volume rasterize attribute based on the density with these parameters and the voxel size and particle scale. I add a pyro solver. As I mentioned earlier, I want to keep the sphere shape, so I didn't touch a lot of the pyro solver settings, but I want a little bit of variance in the smoke. What I did in the pyro solver, in the setup I just change the voxel size and the velocity voxel scale. In the sourcing I delete everything and I added the density and the bell. And in the shape I add some turbulence and some sort of viscosity. And that's it for the smoke, really. And to give it a little bit more detail, I decided to make some particles based on the curves with a simulation very similar to the one that we just made for the smoke source. And this is right here because I want to take the control of the how many points I want to be the emitters. I make a scatter node into the lines. The pop simulation it's basically the same, but the only thing it changed is the pop source emission type to all points and the scatter node. And that's it. Okay, so we are now on the stage context, and as you can see, I finally use two smokes. As you can see earlier, I made two streams of the smoke because I want to test if I want the inner smoke or the outer smoke. So I finally used both of them, but with different density into the material, right? As you can see, the lines are a little bit thicker, something that I don't want to, but this is what happens when you import curves into Karma or points. Treat it like in a default value, and you can tweak it with a render geometry node. In the geometry tab, you can set or create the width scale, and this is the value I chose. The same thing happens with the particles, with the points. Make sure when you add a render geometry settings or a geometry light like this, make sure you are selecting your object by importing from the same path you choose. So in my case, the particles are in Rasengan. Inside of particles, I have the points underscore 0. And after adding the materials, we have this for the lines. I added some emission. I imported the color and I plug it into the base color and into the emission color, and the emission is just I turned up the emission till I like it. For the particles, the emission is the double of the curves, but because I want particles to be like an emission light. I have some problems with this because I thought this would be in the render geometry settings, but they made a particular node for this. It's called the geometry light. The particles are lighting everything up. So well, this is the result of the Rasengan effect. But before to end the tutorial, I want to advise you from something I learned during this project. If you go to the OCIO settings, now the color space Houdini is using. Well, I'm saying that because when I import things into Nuke or DaVinci, I find really hard to find the same color space so that it ends up looking identical in compositing and post-production. So I'm going to show you, if you have the same color space as me, what settings I used in Nuke and in DaVinci. Well, for DaVinci, I just import my raw render, and if you press S on the node graph, you can go to the color tab, and the color management, use OCO and custom, and you have to take the same file as Houdini is reading to render. I find it here in the documents folder inside your version of Houdini. There's a audio folder and the audio file. And also make sure you are exporting this in EXR because if you are exporting in PNG or JPEG or something like this, then DaVinci can't read the color space. And for DaVinci, I just go to the color tab, I just go to the node library and take an assist transform. In my case, I take these settings for me. If you go back to Houdini and check the color space is linear and rec 709 in sRGB. In DaVinci, I choose ACES 2.5, input transform sRGB linear, and the output transform into rec 709. I hope you learned something today. So have a happy Sunday. I hope you enjoyed the tutorial and thank you for watching.